Today we're looking at proving that a quadrilateral is a parallelogram. So this is kind of the converse of everything we were just doing. Remember converse, a conditional statement says, if P then Q. The converse reverses that, if Q then P. It reverses things. That's what a converse does. We also had the inverse and the contrapositive earlier this year. By the way, that whole logic thing, if you go on and take a college math class, I'm actually helping a person right now with a college math class, a guy I know, older guy, went back to school, my age, is taking a college math class. And tons of logic and inverse and contrapositive and that sort of stuff. That's a very introductory level math class. So that whole concept of inverse and converse isn't just a geometry thing. That's a pretty big college idea of the idea of logic. So remember converse. Basically, in our last section it said, if it's a parallelogram, then the opposite sides are parallel. Both pairs of opposite sides are parallel. This reverses that. If both pairs of opposite sides are parallel, then a quadrilateral is a parallelogram. And basically it's the converse of everything we've learned. The ways to prove that something is a parallelogram. Parallelogram. Can't say the word today. Okay? We can show both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One pair of opposite sides is both parallel and congruent. That's a new one. This is not a converse. This is something different. We'll talk about that a little more in a second. Or show the diagonals bisect each other. Now, most of the homework is going to look identical to what we've been doing. They just phrase the question differently. So instead of saying ABCD is a parallelogram, find the values of X and Y, which is what the instructions were the last 2 days, now it's going to say what values of X and Y would make ABCD a parallelogram. It changes nothing about how we set up and solve the problem. It's just that it's asking it in the reverse now, saying instead of giving that this is a parallelogram, so I know opposite sides must be congruent, we make the opposite sides congruent, so it must be a parallelogram. So we have to set up and solve equations. Nothing new. How would I set this up for x's to start with? Okay, and that's pretty easy. I get 3x equals 24, so x is 8. So if x is 8, then these sides are going to be congruent, right? If x is anything but 8, they aren't going to be congruent. Only when x is 8. How about for the y's? What's the equation? So again, fairly simple. Subtract the y, add the 3, I get y equals 10. So when x is 8 and y is 10, then this shape is a parallelogram. Any other values, it's not going to work. Which method are we using to show it's a parallelogram? Both pairs of opposite sides have to be congruent. Once that happens, then it's a parallelogram. That's just one pair of sides. Now the other thing we're working on is, I said was new, is what happens if we say just one pair of sides is congruent, but then we also know that same pair of sides is parallel. That's sufficient to show it's a parallelogram. If I know the sides are parallel and they're also congruent, one pair, same sides, parallel and congruent, that's enough to show it's a parallelogram. If they aren't the same sides, it doesn't work. If I said these sides are parallel, okay, A, B, and C, D are parallel, and 6x and 3x plus 24 are congruent, that doesn't prove it's a parallelogram. It's possible to have one side's parallel and the other pair of sides congruent. If you're not sure about that, look at this little picture. Okay, these two sides are parallel. Those two sides are congruent. Is it a parallelogram? No. It's a trapezoid. In fact, it's an isosceles trapezoid. We'll learn later. We call that. So it's the same pair of sides has to be both parallel and congruent. Not one pair parallel, one pair congruent. That won't necessarily work. We'll talk more about that shape this week and into next week. All right. Describe how I could prove that ABCD is a parallelogram. We don't have to write the full proof. We're going to kind of describe it. Yeah. What do we know? Okay. So angle DAC would have to be congruent to angle BCA because alternate interior. Okay. But actually we're given that they're congruent, aren't they? So since we're given they're congruent, what does that tell me? Okay, that which sides are parallel? AD is parallel to BC because of alternate interior, and we're also given that AD is congruent. Congruent to BC because it's given. See, it's not a full formal proof, but we're describing what's going on kind of in the same method. We aren't making the two columns, but we're doing the same thing. So one pair of sides parallel and congruent. There it is. That must be a parallelogram. And that can be our explanation. That's our proof. But it's the same basic process of proof we've seen before, just without the formal two-column statement reason thing. We're still making statements. We're still giving reasons. Just without the two columns. Now, some people, that freaks them out. They say, I'd rather do two columns. Fine. Do two columns. It's not going to hurt. You can set up your statements and reasons. AD is congruent to BC, given. Angle is congruent to angle, given. Side is parallel to side. Alternate interior angle is converse. ABCD is a parallelogram. One pair of sides parallel and congruent. Write that out. 15 years ago, you would have been writing that out. Not so much now. You're more just doing a description as to what's going on. But again, it's showing the idea. And by the way, for those who aren't sure about, wait a minute, which sides are parallel based on these angles? Make the Z. Make the Z. The Z will show me the parallel sides. AB and CD don't enter into it, do they? They don't enter into that Z at all. The parallel sides are AD and BC. So draw in the Z if you need to. That's really all that's new today, is we're just working it backwards. That's all we're doing is working it backwards. And the assignment is going to look really similar to what you've been doing the last few days for the most part. Yeah, you're going to have time to work on it. Solving for X. Now, 11 through 14 we're going to look at tomorrow, which is we're going to move it all into the coordinate plane, so be prepared. Have your distance formula, slope formula, and midpoint formula note cards ready to go for tomorrow. Because we're going to use them, you're going to need them. Make sure you're not at distance, slope, and midpoint because we're going to get into the coordinate plane. Not so much for today. So, not too tough. 4 through 10, 15 through 23. Actually, just go through 21. Yeah, 22. Go through 22. I want you to write one biconditional. You don't have to write them both. So make that 22 instead. So 23. And you may have to review what is a biconditional. You might have to go in the index and look that up to see how you write a biconditional again. It's okay. Good review. Not going to hurt you. And tomorrow we'll be working on the coordinate plane. Wednesday is the review sheet. Thursday is the quiz. I will try to get that review sheet run off ASAP so people can get that. And